Hello, and thanks for using TickBoom, a free service that helps high school students with their math problems. In this video, I'll be answering this question here, which was sent through to me by a student. It tells us to let the points P1, P2, and so on up to Pn represent the nth roots of unity L1, L2, and so on up to Ln, where the point Pk corresponds to the complex number Lk. We're told to suppose that A represents any complex number Z such that the modulus of Z equals 1, or in other words, Z sits on the unit circle, which I think is relevant because the nth roots of unity also sit on the unit circle. So it's basically telling us that this complex number Z sits on the same unit circle as the nth roots of unity. The question then asks us to show that APK squared is equal to Z minus LK times Z bar minus LK bar for all the values of K. So, yeah, it's an interesting question. I'll give it a crack. If you do find my explanation helpful, please be sure to give it a like. And if you're someone who wants to keep their finger on the pulse with the kinds of questions that other students are struggling with, be sure to subscribe to my channel so that you can stay in the loop. Alright, so I'll just start by writing up what we're being asked to show. So we want to show that APK squared is equal to Z minus LK, Z bar minus LK bar. So that's our challenge, and I think a natural place to start here will be to draw up an Argand diagram. So I'll just quickly sketch one up. So normally when dealing with roots of unity questions, you have to, or you're told the number of solutions, but here we've just been given the generic n. So we're not going to be able to draw up all of the roots of unity, but I'll just sketch up what we need to deal with this question. So I'll just draw a unit circle here, since we know our roots of unity and our complex number z sit on the unit circle. And so I'll just plot this point A, which represents that complex number z with modulus 1, so it sits on the unit circle. And then so that's A. Now the generic pk, the kth root of unity, we can really put anywhere. I'll just put it, let's just put it here, pk. And so in looking at APK, what we're really concerned with is the distance between these 2 points. So maybe what might be helpful is if we define some of these points. So let's call A is related to the complex number Z. Let's just define that as x plus iy. And PK, that point, corresponds to the complex number LK. And let's just define that as A plus IB. Now, maybe what I'll do visually, A, now with these definitions, this kind of distance here up to A, that's the distance x. And this distance, the vertical distance, is y. And this distance here up to P in the horizontal axis is what I'll call B. Now B is kind of, it could be positive or negative. In this case it's going to be a negative number. Oh sorry, this is A. This is A, which could be positive or negative. In this case it will be negative. And this vertical distance is B. And really if I just overlay kind of these lines here, we can see that the distance between A and PK is essentially, we can get there with Pythagoras really, and thinking about this height and this width. And so maybe that's a good place to start. If we think of the line APK, the distance between that, as the magnitude of Z minus LK, And then if we insert our z and lk, so that'll be the magnitude of x plus iy minus a plus ib. And then I'll just bring the real and imaginary parts together. So we'll get x minus a plus y minus bi. And that, we know, is the square root of x minus a squared plus y minus b squared. And that's because we know in general the modulus of a complex number is the square root of x squared plus y squared. Here, instead of x, we've just got x minus a, and instead of y, we've just got y minus b. But you could also see that visually, because this distance here is y minus b, and this distance here is x minus a technically, but a will be negative, and that's how you get the fact visually we see we're really adding them up. But it's really x minus a, where a is negative in this case. So you can kind of see visually this is the result we get. So if we then square both sides, we'll get apk squared equals x minus a squared plus y minus b squared. And that's a good start, because what we've got, apk squared, is the focus of what we're trying to show. So from here, I think all we need to do is take this right-hand side, expand it by putting in our definitions, and see if we get to this result, because if we do, then the two are equivalent. So if I say, well, what is z minus lk times z bar minus lk bar? And in this case, z bar would be x minus iy, and lk bar would be a minus ib. So if we just insert those, so we'll get x plus iy minus a plus ib times x minus iy minus a minus ib. And I'll just expand that, so we'll get x minus a as our real part, plus y minus bi, and here we'll get x minus a minus y minus bi. You just need to be careful with your negatives here. So we've got minus y, yeah, and then minus b would be plus b, minus b, yeah. Okay, so now in terms of expanding this, because I know I'm trying to work towards something with x minus a, y minus b, I might just keep these within their brackets and treat them as individual items. So we'll get x minus a squared minus x minus a y minus bi, and then we'll get plus y minus bi times x minus a. So I'll just write that as x minus a y minus bi, and then we'll get minus y minus b squared I squared. And so simplifying that, we can see this x minus a, y minus bi, they'll cancel because we've got 1 minus and 1 plus. So we'll get x minus a squared, and this minus and the I squared, which is negative 1, will combine to be plus y minus b squared, and that's what we were hoping for, because that is what we showed was equal to apk squared. So therefore we can conclude that apk squared is equal to z minus lk, z bar minus lk bar, as required. So there you have it. I think you probably could have got away without drawing up an Argand diagram here. You probably didn't need to, but I think it's helpful to kind of visualize what you're dealing with. I think for me, once I'd plotted it up and saw that I'm really looking at the distance between 2 points on a unit circle, that kind of helped me then just break down what I was dealing with and kind of think about dealing with the left-hand side and the right-hand side separately and just proving that they ultimately ended up being equal to the same thing. So hopefully you found that helpful. Again, if it was helpful, please give the video a like. That's how you can let me know. And again, if you're the type of person who wants to keep in the loop on the kinds of students the kinds of questions that other students are struggling with, then be sure to subscribe to my channel, and that way you can keep in the loop. So yeah, hopefully you found that helpful, and tick boom.